Hello everyone, welcome to the CloudLearn AWS Zero to Hero series. This is a day 30. In this video, we are going to talk about network address translation. In the previous two videos, we have seen what is a virtual private cloud and how to create our customized VPC in which we have a public subnet and private subnet. And also we observed in the private subnet instances, whatever the EC2 instances we created in the private subnet, they don't get any public IPs, and also we cannot browse internet from the private subnet machines. But in the real time, we might require internet browsing facility, which means from the outside, those private subnet machines can't be accessible, but from the private subnet instances, we can access everything like one-way internet, like how we are getting internet access at your home. You can access internet from your laptop, but your laptop doesn't have any public IP and hence it cannot be accessible from the outside. And how we should provide internet browsing facility in the private subnet is with the help of network address translation. First, let me define what network address translation is, and then we can see how the NAT or network address translation works. So, network address translation or NAT, both are same. NAT is the process of sharing the internet connection with the private subnet, or we can say local network. Local network is obviously a private subnet because in the private subnet we don't have any public IP addresses, and also the NAT will never assign any public IP to the private subnet instances. Why? If there is a public IP assigned to the private subnet instances, it will be no longer a private instance, right? And this NAT will allow never allow any incoming traffic from the outside of the network, or we can say from the internet. Means, what is the purpose of private subnet? To make it more secure. To make it more secure. If someone is able to access from the internet, then there is no security, right? That's why it will never allow any traffic from the outside. Okay, first let us talk about how this NAT works. I will compare this with our home internet. Okay, so assume you built a home network. You built a home network. Let us say here I have a switch and I have, let us say, three machines, three computers. Let us say one, two, three. It can be laptops, desktops, mobile phones, whatever. And these are connected in your home network. You can consider your home network, and each machine will have an IP address. Let us say 192.168.0.11, and it is having 192.168.0.12, 192.168.0.13. All these three are in the same network and they can communicate with each other. But whenever the machine one tries to reach google.com or yahoo.com, it's not possible because they don't have a public IP address. Then here we will maintain a separate server which is connected in the same network, let us say NAT, and here it will have an IP address like this, right? And what we do, we will approach our internet service. You can consider this NAT machine as a wireless router, your router or the modem provided by your internet service provider, because those routers will have the inbuilt NAT service running. So what I do, I will approach my ISP, internet service provider, and I will request that, okay, I need an internet connection. So what they do, they will use a cable or something and they will give you internet connection and they will provide you a public IP address. So what happens here, this NAT computer can reach the internet because it has the public IP. Then this NAT service can share that internet with your local network. How it is possible? How it is possible is because of the service called network address translation. So here, whenever your private computer try to reach the internet, it will translate the private IP address into the public IP address, and then it will allow your machine to reach the internet. Let us say here there is a google.com website. Now from computer one, I want to reach google.com. That's why if you check the IP address configuration in your computer by typing ipconfig, it will show you something called a default gateway. Always the default gateway is going to be the NAT server IP address. Means whenever from the computer one, if I types google.com, first the request will go to the NAT server. The NAT will remember, okay, the computer one is requesting for google.com. At the same time, the computer 2 is trying to access yahoo.com. It will remember, okay, the computer 2 is trying to access yahoo.com. Now, on behalf of the computer 1 and computer 2, your NAT machine will go to the internet. It will get the web pages, and the same web pages will be delivered to the respective machines. Means the NAT machine acts behalf of your local network to reach the internet. To reach the internet. That is what the NAT is. And on Amazon, we have two types of NATs available. One is NAT instance, and the second one is NAT gateway. And this is outdated one because it is a kind of a NAT software running on an EC2 instance, which doesn't provide you the high availability, high scalability, and all. And hence, everyone is using the NAT gateway. Okay, right. Now let us write down a few points about what NAT gateway is, and then we can move on with the practical, like what is the NAT and how to create the NAT, how to enable internet connection on your private subnet. Everything we will cover in this particular video. Okay, I can say like on AWS we have or we can create two types of NAT. One is NAT instance, I can say outdated, and the second one is NAT gateway. Just a point, NAT instance is an EC2 instance in which the NAT software is installed and running, which doesn't offer you the high availability, high scalability, and all. Because whenever you create an EC2 instance, it has some limitation, right? The network bandwidth, T2 dot micro or T3 dot micro will give you low to moderate network performance. But what if you have like 100 computers in your private network and all 100 computers are trying to download something from the internet? It will create a bottleneck, right? There are a lot of challenges with this NAT instance, and hence no one is using the NAT instance. Everybody is using the NAT gateway. So coming to this NAT gateway, the NAT gateway is AWS managed, highly available, and highly scalable service. What is the meaning of that? Highly available and highly scalable. First of all, it is a AWS managed service, which means we don't install anything, we don't manage anything. Just we will create it, and AWS will maintain and manage that particular service. And they will offer you high availability, irrespective of availability zone failure and all. Your NAT gateway is available like 24 by 7. Highly scalable. Highly scalable means whenever your local network, whenever your local network is using more and more internet bandwidth, automatically that NAT gateway is going to scale up to support maximum network bandwidth. To support maximum network bandwidth. That's why everyone is preferring to use a NAT gateway instead of NAT instance. Instead of NAT instance. Okay. Now, what are the challenges? Not challenges. What are the key points about the NAT gateway? The first thing, is it a free of cost? No, it is not a free of cost. The NAT gateway is chargeable on an hourly basis. How many hours of time you have used, the NAT gateway is running, for those many hours you will be charged. I can say NAT gateway is chargeable on per hour basis. And then this NAT gateway requires an elastic IP address. It requires an elastic IP address. Okay, so already we have a setup, right? What is that setup? We have a private subnet, which we create in the last video, and we have a private subnet instance also. Before doing the practical of the NAT gateway, first we will check, is there any internet connection on the private subnet instance? Then we will deploy the NAT gateway and we'll verify that the internet is available on the private subnet instances. Okay, right. So here I can say create a NAT gateway. I will say my first VPC NAT, just the name of the gateway, and provide internet access to the private subnet of my first VPC. That is the name of the VPC. What are the steps? Already I said NAT gateway requires an elastic IP address. So allocate an elastic IP address first, and then create NAT gateway using the above elastic IP address. And this NAT gateway must be in the public subnet. Because if you create the NAT gateway in the private subnet, first of all, that NAT gateway doesn't get the internet, right? Doesn't get the internet. Then how can it share the internet with the other networks? That's why it must be in the NAT gateway. Okay, everything is ready. Now the question, how your private subnet instances knows that to communicate with the NAT gateway in order to reach the internet. That is possible by creating an additional route. Create an additional route in the private route table as below. The route table, what are the things that the route table contains? A destination and a target, right? Okay, so here I can say the destination and the target. By default, you will get a default route, right? That also I will mention, that is not required to create because that will be automatically created. 192.168.0.0/16, that is a VPC CIDR, and the target will be local, and this is the default route. It was automatically created. Now we need to create like this. I will explain what is the meaning of this. This is going to be additional route. Okay, so google.com. So what is the IP of the google.com? Let us say 10, let us say 12.13.14.15. So what happens? First, the request will go to this particular route, but that Google's IP doesn't belong to this range. Then it will go here, and all other IPs belong to 0000, which is a broadcast ID. Then it will go to the NAT gateway to reach that particular destination. That is the meaning of this one. Okay. Now, first, what I do is before creating the NAT gateway and all, let us check the login to the private subnet machine. Here it is. And then we will check the internet connectivity. These are the details which I grabbed from the previous session, which we created. First, I am logging into the Bastion host. From the Bastion host, we can log into the private subnet. That is a process, right? There is a process to log in. There is an alternate way also, like using a VPN and all. That also we will see once we are done with the VPC concept. Okay, so we are logging into the Bastion host. Once we logged in, I will log into the private subnet instance and I will verify the internet connectivity and will confirm that there is no internet access over there. I mean, there is no possibility to browse the internet. And then we will continue with the NAT gateway setup and all. Okay, so here are the details of the private subnet instance, which I copied in the previous session. Okay, here is the password. Hmm, what happened? Okay, let me check whether the instance is over there or not. How to verify login to our AWS account? Let me go to the EC2 service. Okay, private instance 2.75. What happened? Let me stop and start. Let me stop and start the private subnet instance. Okay, because here I can see in the status checks 1 by 2 checks passed means something is wrong in that particular network or whatever. So here we have a chance to discuss something. So what exactly happens whenever you stop and start the EC2 instance? So whenever you stop and start the EC2 instance, your EC2 instance will be started on a new hardware in the backend. We can't identify that. If something is wrong with the underlying infrastructure, right? Then automatically Amazon moves, or we can say every time whenever you stop and start, your EC2 instance will be up and running on a new hardware wherever there is a sufficient storage network exist. Okay, right. So here let us do that, because here I can see I was able to see 1 by 2 checks passed. If you go back the video like few seconds back, and you can see 1 by 2 checks passed means there was one warning. There was one warning. Okay, if you don't want to wait, I can start a new machine and we can do that also. Let me start instance. Now the instance will be started on an effective hardware. Just wait for like 1 minute or so. And here, let me try. Might be the instance might not be ready because it takes at least minimum 1 to 2 minutes of time to start any Windows machine. Still, you can see the status check is initializing. Whenever you see like this with a green 2 by 2 checks, 3 by 3 checks, which means that the machine is healthy. Sometimes you can see 1 by 2 checks passed, which means there must be something wrong. If you click over there, it will display what exactly the problem is. If there is a problem with the storage, if there is a problem with the network, you can feel degraded performance. Then simply you can stop and start. Automatically, your machine will be up and running on a new hardware. I mean, the available hardware, which might resolve the infrastructure related issues. During that particular phase, the public IP address will change. you might get a new public IP address every time whenever you stop and start, which we learned in the EC2 class, right? The reason is because your machine is going to be on a new hardware or a different hardware. But the private IPs will never ever change unless you change it manually. You can see the same private IP address. Okay, so let me check. Mm, There might be something wrong. I will do a simple thing. Quickly, I will create one EC2 instance in the private subnet. I will name it as a private new. Okay, I don't want to use 2025. The reason is it requires a huge RAM and all, and we are using T2.micro, which is like 1 GB RAM and one CPU. Because of that, also there might be some issues with health checks, high CPU utilization, high RAM utilization, and all, and we might not be able to log into the machine sometimes. Okay, okay, T2.micro, keep pair, and VPC is going to be our my first VPC. Subnet, not the public subnet, private subnet. Security group, it's a Windows machine. I will choose that. Yep, now launch instance. Our EC2 instance is getting created in the private subnet. See here, it got stuck at the initializing stage. I suspect there might be like a hard disk space issue. The thing is, I kept my username passwords public, right? Someone might log in and they might have filled all the what we call that storage, or they might running some commands or something which might utilize CPU or RAM. In such cases, our system might not be accessible. That's why always we need to store your credentials in a proper way. You must secure all those things. Okay, anyways, we're creating a new one. Let me grab the details. Here it is. Here is the IP. Username is going to be the same, and the password. How to get the password of a Windows machine? Do you guys remember? Yeah, select the instance, click on connect, select the RTP client tab, click on get password. Please wait at least. This is a common thing, right? Because it might take up to 4 minutes to generate a password for your newly created EC2 instance. And moreover, once you're done with your practicals, always delete all your instances. In the real time, we never delete anything, but here we are learning, right? I don't want to pay any money for learning. That's why once we're done with your practical, just clean up everything. Also, keep in your mind that the moment once we are done with the NAT practical, we must delete the NAT gateway and you must release the elastic IP. Because if you keep the elastic IP without associating with any network instance or any network interface or any instance, then that elastic IP is chargeable. So once you're done with your practical, release all unused elastic IPs to avoid unnecessary charges. Okay, so here is the one. Let me check one more time. Okay, let me upload the private key file, decrypt, and here is the password. Okay, now let me log into the private subnet instance. So this is my Bastion host. Let me open remote desktop connection. What is the private IP of my private subnet instance? 192.168.2.169. Click on connect, Configuring remote session means it is able to communicate with your private subnet instance. Username administrator. Here is the password. Accept yes. So we will be logging in to the private subnet. The moment once we logged in, we will verify the internet browsing facility. But if you are using Internet Explorer, every time it will ask you for a confirmation. Would you like to proceed with so and so URL and all? If you install Edge browser, if you have an Edge browser in that machine, it will not prompt you for those things. That's because of IE enhanced security. By default, on all server operating systems of Windows, they enable IE enhanced security by default. You can off that, or you can use a different browser like Edge browser or a Google Chrome or a Firefox or whatever. I think in the last video, I might have shown you how to disable that IE enhanced security. Just use that option to get rid of unnecessary clicks and all. For the first time, it will take a couple of minutes to load that EC2 instance because it will create a profile for the logged in user for the first time. Okay, so it's about to load. Okay, let me click on start just to open any browser. And remember, we are using t2.micro under free tier and we have limited resources. We have limited resources. That's why performance will be, I can say, worst. You might say, okay, why don't we create t2.large or t3.large, x large? Yes, we can, but why should we pay, right? That's okay. So here we have Internet Explorer. Let us disable that IE enhanced security. How to do that? Open Server Manager. Click on Start and Server Manager. Just an optional step. There's an optional step, not mandatory, because I feel irritated by seeing those pop-ups and all. That's why. Go click on local server, and here you can see IE enhanced security configuration is on, right? Click on and off it. Okay, now let me close this server manager and you can open Internet Explorer now. Still it is processing. See here, you can see something. Yeah. Okay, off. Let me close this and let me open Internet Explorer. We haven't created the NAT gateway yet. Just we are checking the internet connection before creating NAT gateway. Okay. So here I will type google.com. There is a before NAT gateway. You can wait like 1 minute or 2 minutes and you can see page not found error. It is waiting for google.com to receive a response. See here. You can wait and you can check. Now, what I do is I will minimize and let us go with the NAT gateway part. What is the first thing? What is the first thing? We should allocate an elastic IP address. How to allocate the elastic IP? Same, the EC2 service on the left side. You can see an option called elastic IPs. Click here. I don't have any elastic IPs because I release once I am done with my practical. Allocate elastic IP address here. And you can add a tag like name. And I use a tag called this is for NAT gateway, just for identification purpose. Allocate. And you can see elastic IP, public IP. What is the elastic IP means? A fixed public IP, which will never ever change. Okay, then what is the next step? Creation of NAT gateway. How to create the NAT gateway? Just navigate to VPC service. In the search box, you can type VPC. Here, click on VPC. In the VPC service page, on the left side, if you scroll down, you can see an option called NAT gateway. Where is that NAT gateway? Here it is. Under virtual private cloud, you can see an option called a NAT gateway. Just click on that. Click on create NAT gateway. I can say my first VPC dash NAT just for identification purpose. You can use any name and make sure that you are selecting the public subnet of my first VPC. It must be a public subnet of your VPC. Connectivity type public, elastic IP allocation. See here, this is the NAT gateway. This is the name which we have given at the time of allocating the elastic IP. If you don't have any IP allocated, just click here. A new IP will be allocated and that will be associated with the NAT gateway. Okay, click on create NAT gateway. This will take some time. See here, state is pending, which will take 2 to 3 minutes of time. In the meanwhile, let us go with the third step, which is creation of additional route, right? Okay, how to do that? The same VPC, go to the route tables, click on your private route table, check the routes, only one route, which is a default route. Now click on edit route, add route. Here, select 0000/0, target NAT gateway, and then click here and choose the NAT gateway. I mean, to which NAT gateway the traffic to be routed. Select that and click on Save Changes and done. Once the NAT gateway is ready, your private subnet instances are able to communicate with the internet. But still, your private subnet machines will not get any public IP assigned. So nobody can see your private subnet instances from the outside. Let us wait for the state to be available. Once the state is available, we are good to go with testing. Just wait for like 1 or 2 minutes of time, please. See here, what is the state now? Available, which means your private subnet instances can browse the internet. Before NAT gateway, google.com is not reachable, right? Okay, now let me check. I will open a new tab. Let me type yahoo.com. Okay, if you are unable to see the internet and all here, just close the browser because earlier DNS settings and all might get cached in your browser. So if you're unable to access, close the browser and open. Then google.com. See here. And then Rediff. And then let me try one more. Yahoo.com. You can browse the internet. You might have a question. Does this internet is because of the NAT? Yes. If you want to check, delete the NAT gateway. Delete the NAT gateway and check the internet. You can't browse the internet, right? Anyways, we need to clean up, right? So how to clean up? That also we will see in this because if you don't clean up, if you don't delete the NAT gateway, you will end up by paying huge money by end of the day. So here, clean up NAT gateway and all resources. First thing, delete NAT gateway, and the second one, release elastic IP address, right? Okay, how to do that? Just go to the VPC, click on NAT gateways, select your NAT gateway, actions, delete NAT gateway, and for the confirmation, here type delete and then click on delete. Your NAT gateway is getting deleted. Once it got deleted completely, you can't release the elastic IP. Once it got deleted completely, it might take 5 minutes, up to 5 minutes of time. Then go to the elastic IPs, select the elastic IP, actions, release elastic IP. But here you can't release it. Why? That elastic IP address is associated with a NAT gate. Just we have to wait up to 5 minutes of time. And you can see still it is getting deleted. Once it got deleted, if you want, you can go to the private subnet instance and you can click something and it will gives you page not found error or the page could not be reachable. See here, something like click here. It is trying to load. Okay, let me try aws.amazon.com because NAT gateway is already not in service. Not in service. So definitely you will get an error. See here, it's trying to load. You can wait for a few minutes and you can confirm that you can't reach that particular web page, right? Okay, so this is how you can verify all these things. And then let me check what is the status. Yeah, it got deleted. Now you can go to Elastic IPs, just do a quick refresh. Still it is showing association ID, right? Means in the backend, still the NAT gateway is associated with something. So just wait, come back after 5 minutes, come back after 5 minutes and release the elastic IP. Don't forget, or otherwise per day it might cost you approximately $1. Per day, $1. It's a huge, right? Yes. Okay, this is about NAT gateway. I hope you got clarity about what is a NAT gateway and how we can get internet connectivity on the private subnet instances. If you have any questions on this NAT gateway, feel free to comment out on the video and I will happy to help you out. Thank you everyone.